Okie dokie, we're gonna get started on WebAssign 10.1 for 1524. Let's get into it. Number one, they give us this graph of some function, I guess. They say, what's the sign of the following? So they're asking about like f prime, f prime, f prime, f prime, f prime. Okay, so this is the graph of f of x, and the slope of f of x is positive, then it's 0, then it's negative, then it's positive. Whatever the sign of the slope is corresponds to the sign of f prime, because f prime is the derivative, and the derivative is synonymous with the slope of f of x. Okay? So what that means is f prime is positive here, f prime is 0 here, f prime is negative here, and f prime is positive there. So where the slope is positive, f prime is positive. Where the slope is 0, f prime is 0. Where the slope is negative, f prime is negative. Here we go. F prime of 2, that is right here, so the slope right there is positive. F prime on the interval 1 to 3, that whole interval has a positive slope, so f prime is positive. F prime of 5, right at 5, that's where the 0 slope is, so f prime is equal to 0. D, f prime on 3 to 6. Well, 3 to 6 is the entire 0 interval, so 0. F prime of 8 is right here on this negative slope, so f prime of 8 is negative, which means 6 to 9 is that whole negative slant, which means f prime is negative, and then f prime from 9 to 12 is positive. Hope that makes sense. Let's go to number 2. Consider this function, f of x. Find the intervals where it's increasing and decreasing in the relative max and min. So the process for this is always to start by finding f prime. The goal, ultimately, is to find where f prime is positive, because that'll tell us where f is increasing, and where f prime is negative will tell us where f is decreasing. So finding f prime, 3 times 1/3, that would cancel. You'd just be left with x squared minus 2x plus 1. That's just regular derivatives. That should be a breeze at this point in the course. This is f prime. We always set f prime equal to 0. What that'll do is give us some x values for which f prime is equal to 0, and then those will serve as like boundary points for these intervals for increasing and decreasing. So we solve either by factoring or other methods, maybe quadratic formula, but hopefully it's factoring every time. And we're looking for two numbers that multiply to 1 but add to -2. That'd be -1 and -1. So when we set x minus 1 equal to 0, we find that our only critical point, our only x value that makes f prime equal to 0 is 1. So really that's our only boundary point we need to worry about. So what we do now is make a little chart of x and f prime values, and we throw 1 on there, and we leave a little space left and right of 1. We know that f prime is equal to 0 at x equals 1. That's what we just found out. If we plug in values left and right of 1, they don't have to be immediately next to it, but I'll just choose 0 and 2. You can pick whatever numbers you want as long as they're less than and then greater than 1. We are going to plug in 0 into f prime and plug in 2 into f prime. You can plug it into this version or the factored version. I'm going to use the factored version, and I encourage you to do it going forward just because it kind of helps with the by hand process. So when you plug in 0 here, you get 0 minus 1, 0 minus 1. That's a negative times a negative, and we get a positive. If it wasn't clear, all we care about is the sign of f prime, because the sign of f prime, once again, will tell us where f is increasing and decreasing. So when we plug in 2, we get 2 minus 1, that's positive. 2 minus 1, that's positive. Positive times positive is positive. I guess another way to think about it is x minus 1 squared. No matter what we plugged in for x, because we're squaring it, it would have always given us a positive for f prime. So it turns out, besides that point where f prime is 0 at x equals 1, f prime is always going to be positive. So what that means is f is increasing from here to 1, and then from 1 to infinity. So in other words, negative infinity to 1, union 1 to infinity is where f is increasing. Again, f is increasing because f prime is positive on those two halves of the domain, I guess. So It's increasing negative infinity to 1, union 1 to infinity. And because f prime's not f prime is not negative anywhere, that means it's not decreasing anywhere. So DNE for that.